Hello everyone, I am Divago Chandrasekharan and I'll cover the general introduction of POME. So what is POME? Palm oil mill effluent, or more commonly known as POME, is a high-strength wastewater generated from the processing of palm fruit. If we have a look at the illustration below, we can observe the general flow of palm processing. Fruit bunches are harvested from plantation sites and sent to palm oil mill. Here, the fruit bunches are converted to CPO, which is also known as crude palm oil. It is worth noticing that there are several side products from the mill itself, namely empty fruit bunches EFB, palm kernel shells PKS, decanter cake, and most importantly, POME. EFP, PKS, and decanter cakes are solid waste that do not occupy a large volume and it can be disposed with conventional methods. The CPO earlier is sent to refinery for further fine processing and palm oil is finally produced before packaging and quality control and such. POME is also produced as a result of refining. So, to be exact on the definition of POME, we can say that it is the total liquid waste produced throughout various palm oil processing stages which cannot be easily or immediately reprocessed to obtain useful products. Now, having a look at the illustration towards the right side, it represents a series of processes that take place in a palm oil mill which converts fruit bunches to palm oil. The crucial processes include sterilization, stripping, pressing, separation, and hydrocyclone. It is worth mentioning that sludge from clarification tank and waste as a result of centrifugal separation in hydrocyclone are few of the major contributors to POME from a palm oil mill. POME exists because 100% separation is not possible in industries without high expenses. Therefore, the remaining small quantity of palm oil constituents that end up in the wastewater stream are the main pollutants in POME. Moving on, let's talk about why POME is bad for us. Before discussing about POME, it is crucial to state that Malaysia is one of the largest palm oil exporters in the world, accounting for 45% of total exports in 2009. What this signifies is that a larger amount of palm oil produced would also produce a large amount of POME in return, which can be destructive to the environment. The current method of disposal of POME is partial treatment through separation means before discarding it in water bodies. However, excessive quantities of untreated or partially treated POME even can cause depletion of oxygen in water bodies and result in suffocation of aquatic life. If we avert our gaze to the table on the right, the components and characteristics of POME is provided, which is extracted from Malaysian Palm Oil Board's official website. POME has an acidic pH of 4.2 on average, ranging from 3.4 up until 5.2. There is also about 4,000 mg per liter oil and grease in POME, which is wasted valuable products. POME shows a very high biochemical oxygen demand (BOD) and chemical oxygen demand (COD) value, as well as total solids, which shows how potent it is as a pollutant, especially in water bodies. Other than that, it has a high content of suspended solids. Now, suspended solids in POME would include oil residues, short palm fiber, cell walls, organelles, a variety of carbohydrates ranging from cellulose to simple sugars, a range of nitrogenous compounds from proteins to amino acids, free organic acids, and an assembly of minor organic and mineral constituents. Some of the examples of these mineral constituents would be potassium, phosphorus, magnesium, calcium, nitrogen compounds, so on and so forth. Now, these components can be extracted from POME to reduce the pollution factor of POME as well as to improve the product production efficiency to increase revenue of a palm processing company. Therefore, in this video, we will discuss about the extraction of a particular product from POME through separation or reaction means.
I am Lydia and I will be explaining on the proposed separation method to separate valuable product from POME and the reason of choosing it. We have chosen liquid-liquid extraction as our separation process to extract oil from POME. Liquid-liquid extraction is a process of extracting certain compounds between two solvents that are immiscible or partially immiscible. How LLE works in POME is that LLE separates organic component, which is oil, and inorganic components in POME by adding organic solvent such as hexane or ethanol. This figure shows a simple process of a LLE unit. As we can see, the POME and also the organic solvent are added into the extractor unit. And after the separation process is done, the oil will be extracted out, and also the process will produce raffinate, which is the unwanted product. The first reason why LLE is chosen is that LLE separates components based on their relative solubilities. As we all know, solubility is a chemical characteristic. Hence, it is actually quite possible for LLE to extract entire classes of compounds in the immiscible liquids if it's desired. And for the second reason is that, as stated by Wu and Tu, LLE can achieve high capacity of extractant and high selectivity of separation.
Hi, I am Liu Wai Chun. I will introduce the materials needed for the solvent extraction process. The first material is POME. POME sample was usually collected from the POME pond, where is a wastewater arising at a palm oil mill during the palm oil production process. Other than oil, POME contain high concentration of biological oxygen demand and chemical oxygen demand. Small solid particles and the composition of potassium, magnesium, calcium, zinc, and iron can be also found in POME. Next, solvent. There are few types of solvents can be used for oil extraction in POME. Ethanol is safe to use because it is less explosive and toxic. Ethanol is a non-viscous liquid at atmospheric pressure and ambient temperature, so its extraction and dissolution is fast. Ethanol has low boiling point, which allows the efficient recapture of the ethanol and the subsequent separation of the extracted compounds. It is a cost-effective measure to perform oil extraction by retaining the target properties of the extract. Other than that, pentane, diethyl ether, and hexane can be used for oil extraction as well.
I'm Jinny and I will present about the methodology of the single solvent extraction. First of all, by using the solvent ratio 1 to 15, 10 ml of fresh palm oil malt effluent sample was weighted and mixed with 150 ml of solvent, which is ethanol, in the solvent vessel. Then we'll go to the extraction process. The mixture was left for extraction process for 4 hours. After that is the filtration process. The mixture was filtered and transferred into the separation funnel for complete layer separation. After the filtration is the evaporation process to recover the solvent, so that the extracted oil was transferred into the rotary evaporator in order to distill off all the solvent. After the evaporation, the volume and weight of extracted oil was measured. So after measure the volume and weight of the extracted oil, the drying process was started by sending the sample into the drying oven at 30 degrees Celsius for 48 hours or until the constant weight was obtained. After cooling the sample to room temperature, the volume and weight of the extracted palm oil malt effluent was measured again. And then last is the percentage of oil recovery from palm oil effluent is calculated.
Hi, I am Miza, and now we're going to continue to talk about the statistical analysis and the results obtained from literature review. Right, so one of the ideas is that from 1 ton of crude palm oil, we're actually using up to 5 to 7 tons of water, and what that brings us is that up to half of that water is actually end up used as wastewater, or we can also simplify it as POME, which is the palm oil mill effluent, and that is the main intent of the study today, right? So this is a report given out by the Economics and Industry Development Division by MPUB. So in August 2021, we're actually producing up to 1 million tons of crude palm oil. And even in 2021 alone, it's up to 12 million tons, right? So if we refer to like the logic that we have discussed earlier on, so with that number 12 million tons in 2021, what we get is we're using up to 81 million tons of water, and that is up to 40.5 million tons of wastewater in 2021 alone, right? Okay, so that is in 2021. Let's go back over the years. So 2018, 2019, 2020, almost all of the years are pretty much stagnant at up to 20 million tons, right? So why is this pretty much concerning is because of the characteristics of POME itself. So what we can see here based on this chart itself is the parameter of POME against the concentration, and we can see the suspended solids, total solid, COD, BOD, and all increase is pretty much at a high value as compared to the discharge limit set out by the Environmental Quality Act. As you can see here, 400 for suspended solid, and etc. So if we don't do anything, or if the industry doesn't do anything, it's pretty much going to cause pollution and environmental impacts later on. So that is our main concern here. So one of our methods is via the liquid extraction. And as we can see here, this is one of the studies where they use different types of solvent to look into the percentage of oil recovery. And the types of solvent that they're using is ethanol, diethyl ether, and pentane, and also n-hexane. So these are the trends that we have when the experiment is conducted at 30 degrees C. And ethanol is pretty much the highest. And let's look at the second study we have. This study is also using ethanol and some two other types of solvent, which is n-hexane, n-hexane 2, and also at temperature of 30 degrees C. And we can actually conclude one thing, because they're actually showing a similar trend at which ethanol is the most favorable solvent for separating oil content from POME, because from the result itself, it's showing up to 36% of recovery when the study was conducted at 30 degrees C. So this is due to the polarity of ethanol itself. It's able to dissolve polar compounds as it contains hydroxyl group that can form hydrogen bonding with the solute, and hence improving its capability to extract the polar compounds. When we talk about the other type of solvents and why the reduction of percentage recovery, it's because of them being non-polar, and hence the reduction in the percentage.